Thanks, Chris. I appreciate the introduction. Like Chris said, I'm Dennis from G&N. We're going to talk about piston engine problems today. If you need to get a hold of us for a question or something, you can reach us by contacting us by one of these methods. If you have a old service bulletin instruction that you need a copy of that you can't find, it's no longer printed, we have a lot of these that we're willing to share with you. If it is a current production service bulletin or instruction, I cannot share that with you. So just remember that. But the other ones we'd be more than happy to share. This is a problem that we see not a whole lot of, but we see it more frequently than what we like. This gentleman was putting a cylinder on an engine, and as you're dancing on trying to get it on the engine back through the cowling, he pushed a piston pin through what he thought was the piston. And the problem is it moves. It'll push it up, but it won't go down. So then the rod moves in the cylinder, and it just starts flipping around. Eventually, it will break itself. You can see where it hit the pin to finally break, and then it proceeds to tear the engine apart. This is the top of the rod. You can see how it actually molded itself around the pin. So the best thing to do is just make sure all the pistons are moving up and down after you if you only put one cylinder on, just make sure the piston's going up and down. It's easy to miss when you're trying to get stuff in there. You can see how it originally was that. This is Service Bulletin 632. I've been talking about this since 2008, well, 17, late 17. And some of you are probably getting tired of seeing this, but there is a reason for it. You need to check how the bushing is put into the rod to make sure that it's tight in the rod and it's not going to come out. The tool that Lycoming has provided actually is easy to use. It doesn't take much time. You put it on finger tight till it's snug. You take a reading. You tighten it to 5 turns. You take another reading. They should be within a thousandth or two, a couple thousandths. If it's bad, it's going to move enough that you're going to see it. I've never seen one move a thousandth or two. So they say you're supposed to do the measurement. You're going to know if it's moving. It's not going to be hard to see. That's how much this one stuck out. This is what happens if the bushing comes loose. This was the worst destroyed engine I had ever seen myself. It stopped so abruptly that it actually elongated the washers on the mount, on the airframe. It ruined the propeller, it elongated the holes in the propeller. The gentleman that was flying this, the student, did an excellent job. He put it down on a runway that was about 6 miles from where he took off, and no damage to the airplane. The only damage to the airframe was about a quarter size hole, or not hole, but dent in the top of the cowl. It was amazing. That's the bottom of the rod that failed, kind of the same thing as the first one we looked at. The top of the connecting rod's gone. You got the whole rod to remain down to push stuff and ruin stuff. This is Service Bulletin 645 that came out September 24th of 2021. It addresses the same thing. They've had some more of these. We have found a couple since 17 to now that were loose because we still check every one that we do. So if you have an engine from us, you don't have to worry about this service bulletin because we did it before it left the shop. But this is something that still needs to be done. We do have an extra tool, and we're more than happy to loan it out. What causes this? This is an IO 520 piston that was put in a 550. Bonanzas, Barons, you got a Bonanza that takes an IO 520B or BA or BB, and it also takes an IO 550B. So it's easy enough to confuse the two. The cylinders are the same. The rods, the cylinders are the same, the piston pin's the same, ring set's the same. So it's easy enough to confuse the two. The only difference in the two is the piston, the rod, and the crankshaft. That's the difference in the two because of the stroke difference. You can see on the piston on your left is a 520 piston. The piston on your right is a 550 piston. The only difference in the two from this angle is the cutouts on the 550 piston, which is on your right. From this angle, there should be a pin in there, but we didn't do it because these two sit actually on the skirts that the pin will go through. But you can see the difference in the height of the piston. There's actually that much off the top, and that's why the top will actually hit and the bottom will hit depending on how the casting is on the case. The cases are the same too, if you have a 520B series case. That's the alternator drive gear on a per mold engine. That doesn't belong on the outside of the engine. It belongs on the inside. And this was caused, we see this a lot more than what we want. There's a couple reasons for this. One of the reasons is if the rubber comes loose and starts to flake up. That isn't what caused it on this particular instance. The cause was the cotter pin was not installed correctly, and it started grabbing on the gear as it would go. You can see how it's, in the right-hand picture, you can see how the top is bent and grabbed. We go on, I'll show you how that's supposed to be installed. When the coupling failed, it broke the alternator hub, or the alternator rotor, which in turn let that gear fall around and how it pushed it through the case. To put the gear on and off the alternator, you're supposed to use a tool. There's two little dimples, and you can't see it there, I'll show you later, that tool goes in that holds the hub so you can torque it. Or you can check the slippage to see if that rubber material is holding that gear into the housing. That's the only thing that holds that gear in the housing is the rubber. And it's designed to slip. So that if there's a backfire or whatever, it doesn't break the gears, it'll slip in there. If there's an overload, it will slip. That's how it's designed. Here's the tool on the alternator, and you're checking the slippage. You turn the hub through a 45-degree arc slowly, and then you have the two. The new hub should not slip before you get to 180 inch-pounds. A used hub is 140 inch-pounds. Use a bar, beam, dial, torque wrench. Don't use a clicker. Don't use a vibrator. Use an old style that you can actually move slow and you can read what you've got. This tells you what the torque on the nut is. Each one has a different torque. You have to find what nut you have which alternator, because the smaller ones usually less torque, obviously, than what the larger ones do. You use that same tool to torque that. You can see there how the tool grabs it. Always use a new thrust washer. If you don't use a new thrust washer, there will be grooves, and later, a couple slides down, I'll show you how the grooves form on those. When they form and you put it back on, there's peaks and valleys. You're not going to get them to go the peaks back in the peaks and the valleys in the valleys. And when you torque it, you're going to be short on torque because it's going to settle in where it wants to be and you're going to be off. So always use a new washer. They're not much money in the scheme of things. I think they're 20, 25 bucks. I like to draw the little X on there where the holes are. So I torque it to the low end at the 300 inch-pounds. Then I go ahead and, if it isn't lined up, I set the torque wrench at 450 and move it until it lines up, then put the cotter pin through. Then you bend the cotter pin up and I take a chisel and I score it on the right picture, and you bend it off. The tail cannot go above the shaft. It has to stay above the shaft. When you bend the bottom tail over, it cannot touch the washer. That's a properly installed cotter pin. That will not cause you any trouble. There's an old style coupling that you can use on some engines. You can use it on your engine if it originally came with this style coupling. They will not fail the way the rubber ones fail. There's the washer I was talking about, how you get the peaks and valleys. You see how that's from the coupling moving, doing what it's supposed to do, absorbing the shock and stuff. So that's why it needs to be changed. This one, if you're going to use this over it, if it's on an engine where it was originally installed, when it was new, you can use this. You need to inspect it. You need to take it apart. Now to do that, you just put a couple screwdrivers or lady fingers or little pry bars in between the seam, and you push up, and you can see the spring as it comes apart. It will come out of the top or bottom. They do it different ways, and then that's apart. Once you get that to separate, and you put the spring or the gear in the housing or the other part in a vise, and you twist the spring opposite of rotation, it will snap right out. It'll come right out. At that point, you can clean all the components. You notice you can disregard the washer because you can see the peaks and valleys in that one too. You can see the two different part numbers on the spring. That's for clockwise and counterclockwise rotation. If you're putting the same coupling back on the same engine, you don't have to worry about that. If you're switching, you're going to need to make sure that you have the correct part number with the correct engine. Otherwise, it will slip all the time and it will burn up. It will actually fail, put metal through the whole engine. If you look at the bottom slide, you can see the hub on your left is tack welded. The hub on your right is welded all the way around. The hub on your left is a reject. You should not use that. It will fail. They have to be like the hub on your right. Once you have had it magnafluxed, you clean it. You make sure the bushing and the pilot there are not worn or scored, excuse me, you can start to reassemble. You should put some lube in there, lube the spring a little bit, set it back where it goes, set the top portion on, and you just push it together. Once it'll snap together. Once it's together, you're ready to install it the same way as you do this version of drive. Now, the tool to hold this drive is different than the tool to hold the rubber drive. It's a different diameter. So if you have those, you're going to need two different tools. And we made our own. It's easier to make them than trying to find them. Once you mount the hub on an alternator, you've changed the alternator. You should check how it meshes with the drive gear. If you put a little Persian blue on the teeth and turn it through, you can see where it's meshing. If it meshes too close to the rubber drive, it will tear the rubber drive up. If that's the case, either something's installed wrong or that alternator or drive is not going to work with that engine and you need to switch something. 500-hour inspections on mags. These are very important. It's unbelievable some of the mags we see come in. The Bendix mag there where the X's are, that's actually JB Weld. You can see where a cable or something was wearing on it, and it actually wore through the housing where the X is. When I pulled that apart, there was actually JB Weld around the block. So they need to do their 500-hour inspections. This airplane didn't have little over 500 hours on the engine since it was redone. They went to take off. They got about halfway down the runway. The engine started to run bad, and they didn't make enough power. They weren't going to get off the ground. They seen that they weren't, so they tried to stop, and they didn't make it before they got to the end of the runway. And they went through a fence, which tore the airplane up. They said the engine wasn't developing power, so we went down with the feds to do an investigation, and we found that they had done a 500-hour mag inspection on the mag shortly before this. You can see that tower isn't where it was supposed to be. You can also see a burn spot on your about 5 o'clock on the harness housing. You can see the one tower there that was the two that are discolored from the arcing going on, and you can see the one that is all discolored in the bottom on the right side at about 8 o'clock. What's wrong with this when we took the mag apart, the tab on the coil is supposed to be 90 degrees. It's not supposed to be pushed down like that. That tab connects the coil with the block. This is the inside of the coil, of the block. You can see the finger there. It's actually loose from the rotor. So this had more than one thing going on inside. If you're going to do, I mean, the mags, these slicks aren't rocket science, but they do have some quirks. So if you're going to do 500-hour inspections, I would say that it's a good idea if you do them on a frequent basis. If you're only going to do one or two, send them to somebody that does them all the time. It'd be much better off. We'll all agree that this is detonation, common detonation. This is a quill shaft off of a GTSIO 520, and I used dye because it showed the cracks better than what the Magnaflux did for a picture. Those spiral barber pole looking cracks, when the bottom gear, because there's supposed to be a spline on the bottom just like there is on the top, one on each side, when that shaft finally sheared, those cracks were straight. That's how far it twisted. The distributor block is what caused this to do that. You can see in the top from about 11 to 1, those two electrodes, you can see the carbon track going from one to the other. That's what it was, firing the wrong cylinder at the wrong time. The engine was trying, actually, when it would light that cylinder off, the engine was trying to go in the opposite rotation. That's what caused the quill shaft to get the fluctuation in it. The pilot's complaint was that the engine ran away from him. Well, it would have when the quill shaft broke, because he had the prop and the engine were separate from each other at that point. The sad part was that block should have been out of there when this happened, like 10 years previous to that, because that's an old block that there's a bulletin on. This gentleman brought these couplings back. I happened to sell them to him, and he brought the couplings back and said that they were defective. He had the same issue that the previous guy had. Same kind of engine, same thing was happening. The only difference was the quill shaft didn't break in this instance. It tore up the couplings. Now there's a service bulletin that tells you on a Gitzo, which is a GTSIO 520, that when you have this, a rough running engine, a mag cushion issue, you have to take the quill shaft out and Magnaflux it. You have to overhaul the mags, and you have to check the starter adapter, gear, and teeth. So you're better off doing your 500-hour mag inspections like you're supposed to make sure that they stay up to snuff and you don't have to do all this, because pulling that quill shaft, though you don't have to take the engine apart, is not really a fun job. Should you do a top overhaul, or should you overhaul your engine? Time has a lot more to do with engines' calendar time if they're not running than what hours does. This engine is a C85. It's off of an older Cub. It never reached TBO. It was from the 50s. It had a top on it. They were going to do the second top on it, and our customer pulled the cylinder off, didn't like the way the rod felt. He pulled a rod, and then they sent the engine to us. And this is what we found for bearings when we took it apart. The bearings are supposed to look more like the front main bearing on your left. They're supposed to be a coat of Babbitt. The copper is an underlayment that they stick the Babbitt to. There's a steel shell, then they put copper in there, and then they put the Babbitt over the top. Every time this thing started, because it was set so long calendar-wise, it was doing a dry start. As it does that, you wipe the Babbitt off the cushion. The problem was now that he wore so much onto the crank, because something has to wear. So the crank on the early Continental, little Continentals, were not nitrated. So the crank's going to wear before the copper's going to wear. So by the time we got to this, the crank was so bad it wouldn't clean up at 20 under. so he had to buy himself another crank. Experimental aircraft and airworthiness directives. Do ADs apply to experimental aircraft and engines? Yes, they do. Regardless of what some people want to tell you, they do apply. Don't let somebody sell your customer a experimental engine that they've knocked the tag off of and said now none of the ADs apply. Because you can tell if it's a Continental engine, a Franklin engine, or a Lycoming engine, and then you're not going to know what it is, and you're going to have to do AD research on everything they ever made. This tells you it's more about the AC that tells you that they apply. This is an AD on the air regulator plug on a Precision Bendix servo. The gasket on the right is the gasket that they used forever. They torqued to 25 inch-pounds under the brass plug. They never had a problem with it. The gasket on your left, you can see how it's wider. It's kind of fuzzy. The people that made the gasket that they used forever decided they didn't want to make them anymore. Didn't want to be in aviation. So they contracted a new manufacturer to make the gasket for them. And they said it was the same, no problem. Well, the problem was that the material wasn't compatible and it would dissolve. You can tell how it's kind of already flattened out. It's the only one we got that had started to fail that actually didn't fail. They replaced it with the gasket in the middle. Now it's an aluminum gasket that's coated with Teflon to help it torque. The torque went from 25 inch-pounds to 100 inch-pounds. Once you did that, then you can eliminate the AD of checking it every 50 hours. And you stamp a G on the plug. Don't stamp the G on the plug on the servo. It will damage the housing. Excuse me. This airplane is about 200 feet from the end of the runway. It's actually on airport property. Was coming down and the engine quit. He didn't run out of gas. He had a problem. There's that plug off the servo. You can see it hanging by the safety wire. Once that plug comes off, you lose your air pressure on the air side of the diaphragm, and the diaphragms can't work correctly, and the servo will not deliver fuel. And you just run out of gas, but you got plenty of gas on board. So it's a little better picture. You can see the threads on the two. Now you would think because the brass is a much harder material than the aluminum, that the aluminum threads in the housing would go away. They do not. It's the threads on the brass that actually wear away. You could put a plug in that housing and torque it, and it would torque up. But don't use it. If there's any damage to the plug, you should replace that housing. The lead seal on there, you can see an A. You're supposed to stamp who does it. You have a couple letters. It's only got one A. There was never anything figured out who did it. If you look at the tag, we at one point had overhauled this servo. Because under the IC it says G&N. The engine that was in that aircraft was actually a factory reman. It was going through an annual after it had been put in. Nobody knew where or how this servo got on that, if you went over the records, how this servo got on that engine. My guess is this was the original servo off the engine they changed. The one they got with the engine didn't run right, so they put this on, it ran okay, and they left it on. Somebody had overhauled this after we did, though, because that's not the way we safety wire them. And the other thing is that lead seal with the A on it is not supposed to be on a servo. It's supposed to be an aluminum seal, which is different. So I went back through all our records and I couldn't find where we had done that servo. So we have records back to 92, so it was previous to that. So the people that are going to be in trouble on this is the IA that put it in and signed it off, or the A&P, going to be the IA that signed the annual off, that this was through its first annual, and they didn't do their record research to make sure that the accessories match what's on the engine. Nobody likes to do that, but it is a necessary evil. And the owner, I'm sure, knows the whole history, but wasn't going to admit it. This is an 0235 L2C intake valve. This gentleman bought a cylinder, brand new cylinder, put it on his engine, and 25 hours later he's got this happening. What happened was he did not adjust, or there's another thing, but his valve clearance was wrong. For years and years, Lycoming made aluminum push rods for 235s. The clearance was 6 to 12. They have since switched to steel push rods, and the clearance is 2 to 5. Now, if you put a steel push rod in an engine and you set it 6 to 12, you're going to get some clattering. If you put a engine or a cylinder together and you use aluminum push rods and you set them 2 to 5, you're going to do this. So either he didn't set it right, or he had the wrong push rods and initially got the wrong clearance. There's also a procedure if you have all 4 cylinders off. There's a service bulletin that tells you how to load the camshaft so that you will get the right clearance when you're done. If you just start with number 1 and don't preload it right, by the time you get back to number 1, your clearance will be way off. Auto fuel, don't recommend auto fuel in piston engines, aircraft piston engines. If you're going to use it, please use the 92. We've done some work with Swift Fuel, with them trying to develop an alternative unleaded fuel, and we found out that 87 octane car gas may be 82, 81 octane. So still should be enough, but it's really not. So you need to, if you're going to use auto fuel, use the 92, the high octane with no alcohol in it. It's not, I always thought it was the lack of lead that caused the problems with the accelerated wear in the exhaust guides and valves. It's not the lack of lead. I was wrong. It's the lack of octane. The lower the octane, the more heat you get. And that's what wears the guides and the valves, is the excess heat. And if you think about it, that makes a lot of sense, because if you put jet fuel in, you detonate and you melt it because of the extra heat, because of the lack of octane. This engine made, or this piston made one trip around the patch. It's out of an 0235. The gentleman swears that he put straight aviation fuel in it, but we took the engine out, and when I loosened the fuel line, I noticed the fuel was clear and it didn't smell right. They took a sample, and when we had it analyzed, it had 5 times the amount of toluene in it was supposed to. So the best thing you can do is use aviation fuels. If you don't want to do that, please use the 92 auto fuel. This is the air regulating chamber off of a Precision servo. You can see all the dye in there. This is off one of the new 172s. A Precision Bendix servo is allowed to leak 5 cc's a minute, brand new out of the box. That if they're leaking 5 cc's or less, the engine will shut off. There's not enough fuel to run. But it's about a teaspoon a minute. So if you take a teaspoon a minute and you multiply that by an hour, that's 60 teaspoons an hour, times 24 times however long it sits. That's how you get the air in there, because it runs past the manifold valve, the flow divider, because there's no shutoff in a Precision flow divider. So it runs into the cylinder. If the intake valve open, it runs down the intake pipe through the cylinder, gets down into the sump, into the intake portion of the sump, and it hangs off the impact tubes on the servo. When you start the engine, it sucks the fuel up inside the air chamber, which is in there. The fuel's not a problem because it evaporates, but the dye is the problem. The dye is sticky, and it doesn't evaporate, and it gathers on the stem that goes between the fuel diaphragm and the air diaphragm. And it causes the bushing to drag, which in turn causes the servo to run badly. So when they send it in to get repaired, now you're about 4 hours labor plus parts to fix it. So the cure for this is to turn the fuel off when you stop the engine. You just shut the fuel off. Some of the new Cessnas have you pull it and it shuts it off at the firewall. As long as you shut it off to where it can't get the pressure through there, you don't end up with this problem. The other way you get it is over priming. So try not to over prime the engine. That's as bad as leaving the fuel on. You end up with the same problem. Buyer beware. Right now, with the way it's hard to get parts, it's getting worse and worse. I mean, people buy stuff on eBay or wherever they can find it. This carburetor was sold on eBay. The gentleman bought it and he sent it to us. He wanted a low STC done to it. Supposed to be for an 0200, and he paid $800 for it, advertised as freshly overhauled. Well, if you look at it, right off the bat, there's no lock tab safety wire on those screws at all. There's no safety wire on the throttle arm, which is an AD from the 70s, and the drain plug's not wired. There's also no stop pin on the mixture control. So where's full rich, where's lean? Don't know. Same thing on the bottom. There's no lock washers, tabs, or anything. They did go the extra mile and put the nice little covers in the fuel inlet and on the studs. It was nice of them. Then we took it apart. The black block should have been out of there about 25 years prior to that. The accelerator pump, that's a brand new one, which is a required part. The lock tabs are not utilized on the nozzle, and it has a 2-piece Venturi. Now, I know the AD says that you can use the 2-piece Venturi, but I would not recommend it. The 1-piece will work fine with the atomizing nozzle now, and you're much safer doing that. The floats I talked about, the black float, this is a progression of floats. Originally there was brass floats. They went to the black foam float on the left because the brass floats, the hinge pin's soft, the float wears out in that area very quickly. If it gets too loose, it'll rub on the side of the float bowl and it'll rub a hole in it. The other thing that you can do with a brass float, if somebody blows air into the inlet, blowing off the carburetor, and they get enough in there, they can actually collapse the pontoons. The black float worked well until they changed the fuels, and people started using a lot of auto fuel. It will absorb fuel. Some of the additives sink into it or seep into it. I've got a float out of a MA3 that I can put in a container of fuel, and it will sit on the bottom of the fuel. So that's why they quit making them. They went back to the brass float. They then developed the white float, the polymer float. I thought these things were the best things since Post Toasties. They're self-lubricating, so the hinge pin, it never wears out. If it happens to rub on the side of the bowl, it puts a little bit of the material on there and it becomes slick and it doesn't cause a problem. But what happened was you'd put these in and they're welded together. The top is separate from the bottom. And you'd put them in and the guy would say, hey, this thing is running rich at idle and I can't adjust it. You'd get the car back and one of the pontoons would have a chamber full of fuel. And it stays there. You can't get it out. Before they'd weld them together, they'd pressure check them, they'd put them in a atmospheric chamber and check them, they'd submerge them. But when the airplane goes up and the altitude gets thin, it will suck the fuel in there. So they quit using those and they developed the blue float. Now the first one came out in '05. I've seen one problem with one float where there was a piece broke off of it. The piece was in the bowl when the carb got to TBO. They never had a problem with it. I would recommend using the blue floats. They've got the stainless steel hinge pin area. I've had some of them go 3 runs and they're still fine. They also, if you go to Tempest's site, they had a picture with 4 of the 4 or 5 floats on a 2x12 with a car sitting on it. So they're very durable. Excuse me. This is an engine from the time when Lycoming had the crankshaft issue. They do bring those ADs out for a reason. This gentleman did the correct thing. He bought his crankshaft kit for $2,000 when it was available, but he was going to get every minute out of the engine before he had to overhaul it at 2,000 hours or 12 years. So he's flying along one night, and all of a sudden it gets quiet. So he was close enough to an airport. He landed, no incident, didn't hurt anything. Had us pick up the engine, and when we took it apart, imagine that the crankshaft broke. So, still hasn't hurt himself too bad. He had to crank anyway, so the counterweights that got damaged aren't a problem. He's going to cost himself 1 rod. That's not a big deal. The case didn't get busted up. The metal in the sump will clean up. And then he brings me his brand new crankshaft kit. And I start looking at it and I go, well, that end of that box don't look so hot. And I really don't believe that Lycoming is going to pack that crank in a water heater box, because that's what was on the inside of his box, was a inside of a water heater box lining that. And I'm sure they weren't going to wrap it in a nice cotton blanket to keep it warm. That's the front of that brand new flange on that crankshaft. You can see the pits and you can see the rust inside the bushing. Well, there's a service bulletin to polish that and recad plate it, so that's not so bad. We could push the bushings out and replace those. He's still not too bad. And that's the rear main journal on that crank after it was ground to 10 under. So now he's got a brand new crankshaft that's no good at all. So he's got the one that he ran that he was going to get every minute on that left him stranded. And he put this crank in an environment that wasn't friendly for it. So the new crank ended up bad. So he ends up buying or having to have his third crank to get his engine done. If you're going to buy one of these, there's still a lot of these out there for sale that people bought and then they decided to buy a factory engine or something else. That if you're going to buy one of these, please make it on condition that it's going to be usable. Because if you bought this and you didn't, now you're stuck with something that's no good. If you have one of these and you're going to store it, please maintain it in a good environment and keep an eye on it. Keep it coated with a non-rusting, penetrating component that will keep it from rusting, even if it's just oil, just to make sure that it is, well lubricated and preserved. This gentleman had an Aerostar, and he couldn't put oil in it without making a mess, so he'd pop the top cowl off. He came back from his previous trip. He got ready to go on the next trip, popped the top off and noticed this little crack and decided he better not fly. So he ended up calling the feds and they took it apart. We took it apart. This is what we found in the sump, which was off before he called the feds, and then they tagged it. But he pulled this off prior to calling the feds. But you can see the amount of metal in the bottom, most of it being ferrous. And this is what we found when we took the engine apart. You can see all the lifters are busted up. And what happens is you get the pieces. If you look at the lower left-hand picture, you can see two pieces in the case that are embedded in there from pieces that broke, which the top right-hand picture has it after we pulled them out. What happens is you get something behind the lifter, and it works like a fulcrum, and it busts the lifter off. You can see them better there. It acts, and it just keeps, once you break one piece off, the problem just keeps, multiplying and getting worse. This is the actual lifter that started the problem. You can see the nice half-moon type crack on that. You can see the nice half-moon impression right there on the case. Those two line up perfectly, and it matches a 1/4-inch light washer. There's not much room between the back of the lifter and the case on these engines. So if you get something in there, it's going to cause that. That's the only piece we didn't find in the sump, was that washer. My guess is that he had dropped something in there when he was putting oil and didn't think it would hurt anything, and then he fished it out. But we'll never know. That's another reason I'd say don't put oil in an engine without a funnel with a filter. This is a Malibu engine, and it had the same sort of little crack. You can see it there, the little bubble in the top picture right by the the flow divider. So I thought we had the same thing. This is the metal in the pickup screen. And this is the oil pump. With all that metal, you notice that the oil pump is not very chewed up. The housing is almost perfectly fine. This is the crank after it threw the rod. That was the customer's complaint, that he said all of a sudden there was a bang and the engine started running rough. This is the piston that was on that detonated, which actually caused the problem. It wasn't, you can see how much of the piston, it wasn't the rod that actually failed. It was the piston. You can see this rod is fully intact. And what happened was that there was so much metal debris from the piston failing that it actually shut the oil flow off to the engine, with that pickup screen being fully clogged. That's why the screen and the filter did their job, that the oil pump is not all tore up, but it shut the oil off to the oil pump. So that's what caused the rod to fail, which in turn is what caused the whole engine failure. I want to thank you, gentlemen and ladies, for listening to me. I want to thank Chris for doing all this, and Drew. So thank you and have a good day.